Ionic compounds are typically made up of metals and nonmetals. Metals tend to form positive ions by losing electrons, and nonmetals tend to form negative ions by gaining electrons. And we can predict some of the charges based on the group they're in of the periodic table. On the left-hand side, the metals, group 1A tends to form +1 ions, group 2A tends to form +2 ions, and over here in group 3, we have to remember that boron is a semimetal, but from aluminum down, those tend to form +3 ions. Now, if we start at the opposite end of the periodic table on the right-hand side, our noble gases tend not to gain or lose electrons. They're very stable. So those do not form ions. They have zero charge. Going one group over to 7A, fluorine, chlorine, bromine, those tend to gain one electron and form -1 ions. Group 6A tends to gain 2 electrons and form -2 ions. And nitrogen, phosphorus, those tend to gain 3 electrons and form -3. So we can predict the charges based on the position in the periodic table, and we're going to use that to write the formula for different ionic compounds. So here's sodium chloride. That's made up of sodium and chlorine. If we look at our periodic table, sodium tends to form a +1, chlorine tends to form a -1. And so I know that I need one of each in order for the charges to balance. +1 and -1 cancel each other out. So my formula is going to be NaCl. Now let's look at magnesium chloride. So magnesium tends to form a 2+, and then we said chlorine forms a -1. So if I have Mg 2+ and chlorine is -1, I'm going to need 2 chlorines to balance the 2+ of the magnesium. So to get -2, I need 2 chlorines. And so that means my formula is going to be MgCl2 with a subscript of 2. Sodium sulfide. Sodium tends to form +1, and sulfur tends to form -2. So again, here we have a 2- and then a +1. So I'm going to need 2 sodiums to balance out the 2- of sulfur. So if I put 2 sodiums together, that would be +2. 1 sulfur is 2-. That means I need 2 sodium for every 1 sulfur. Aluminum oxide. Aluminum was way over here in group 3A. That we said tends to form a 3+. And oxygen tends to form a 2-. Now here, what we've been doing so far, but was basically easy because we had only +1 or -1, +2 or -2, we were finding the least common multiple. So we were basically multiplying them together. So if we look at 3+ and 2-, our least common multiple, 3 times 2 is 6. So if I want to make 6+, that means I would need 2 aluminum in order to do that. And to make 6-, I would need 3 oxygens. So this gives me 3+, 6+. This gives me 6-. So that means I need 2 aluminum for every 3 oxygen. All right, potassium sulfate. So sulfate is one of my polyatomic ions. So I need to recognize the names of my polyatomic ions. Sulfate is SO4 with a 2- charge. And I don't look at the sulfur or oxygen separately for charges. I treat that as a unit. SO4 is 1 unit, and the whole thing has a -2 charge. So potassium sulfate. Potassium is +1, and sulfate is 2-. So if I look at this, I know that I'm going to need 2 potassium for every 1 sulfate, so that I get a 2+ and a 2- canceling each other out. So my formula would be K2SO4. And calcium hydroxide. So again, hydroxide is one of my polyatomic ions. Hydroxide is not the same thing as oxide. Oxide is just an oxygen. Hydroxide is a group, OH together, and altogether it has a -1 charge. So calcium, calcium tends to form a 2+, and we said that hydroxide is a group, it has a -1 charge. So I'm going to need 2 hydroxides for every 1 calcium so that I have 2+ and 2-. And when I write my chemical formula, if I were to just write OH2 like that, that looks like I have 2 hydrogen and 1 oxygen. I need to make it clear that I have two of that whole unit, two OHs, so I need to use parentheses for that.